Hi again, chemistry. It's Aninga here to help with more of your basic chemistry math. So this time I think we're going to be covering scientific notation and just learning how to look at that for learning how to take this and write it normally, as well as taking your normal stuff and turning it into scientific notation. Okay? So we're going to first start with this side, I think, and looking at how we turn normal numbers into scientific notation. So scientific notation is basically it's a number, a big number that is converted into an easier way to look at it. This might not seem like it matters much for numbers that are small and already easy to look at. And it makes more sense when you have really huge numbers like these numbers, or really tiny numbers, okay? So we take, instead of having this big huge number, we convert it down into something more manageable, okay? And so the values that you see on scientific notation stuff, when it's in scientific notation, it has to be a number in front, a number between 1 and 9, followed by a point with the other values following it. Normally you don't see too many values past this dot, but you know what it is. So those are the rules to follow. You have to be between 1 and between 1 to 9. Okay? And 2, it has to be followed by your other numbers. And 3, if it applies, has to be the correct number of sig figs, or significant figures. We'll get into sig figs later, so right now we're not going to focus on that, but this is one of the rules that it has to follow later on in chemistry, okay? So an example would be like 1.5 times 10 to the 5th power is a example of scientific notation. This number right here represents how many times you go over either to the left or to the right. If it is a positive number, so if it is say 10 to the 5th, this means your number is getting bigger, and so you are going to move your decimal point to the right. Okay, so for example, 1.5 times 10 to the 5th, that means you take 1.5 and you move your decimal point to the right 5 times. 1, 2, 3, 4, 5. And then you put zeros in there. So our new number is 150,000. However, if it is a negative number, like 10 times 10 to the negative 5th, so 1.5 to the negative 5th, this means that your number is getting smaller into the decimals, and so you are going to be moving your decimal point to the left so that it gets smaller. So for example, our 1.5 times 10 to the negative fifth up here, this one, we go 1.5 and we move it over 5 times. For me, to the left. For me, that's something that's helped me with the negatives is this is how many zeros you add. So, and you add them to the left going over. So I add 5 zeros, 1, 2, 3, 4, 5. If you count, and then all you'd have to do is put your decimal in between the final two values, whatever they may be. They might be zeros, they might be a 0 and your starter number. In this case, it's 2 zeros. And then you can count over just to be sure. 1, 2, 3, 4, 5. Look at that. So the reason I do that is because it makes it easier to know where your decimal point should be without having to draw your crazy, like hopscotch arrow. You can just say, oh, I need 5 zeros, and just put your dot in between the last two. Okay? So this is what scientific notation, looks like, and this is what it looks like as an actual number. Okay? If it's with a negative, and this is what it looks like if it has a positive. So what I'm going to do is I'm going to take a couple from our worksheet here, and we'll do that. One for each, one for this type, and then one going backwards. Okay? So I'm just going to grab another sheet of paper here. Oh, where'd my paper go? So I'm going to do number 3 here, and we're going to convert that into a scientific notation number. This one, number 3, is 49,603. With all whole numbers, we have a decimal point at the end always. So if it helps you with scientific notation to put a decimal at the end of your whole number and add a 0, feel free. That is kind of what I do all the time to help me. But, if you don't need it, that's fine. So we're writing our scientific notation. This helps us because we need to know how far over, how high our 10 needs to be and how far over our decimal goes. Now remember our rules that this scientific notation number has to be between 1 and 9. So it cannot exceed the double digits. It can't be 10. So notice our number here starts with 4 and not 49. We cannot have 49.6 times 10 to the whatever. It should be still below 9. And so 4, since it's below 9, but 49 isn't, we're going to start with 4 and put our point in. Okay? And that makes our starter number lower than 10. 0.9603. We're following our second rule. Our first number has to be between 1 and 9, which it is, and it will be followed by the other numbers as stated by our second rule. We're not worrying about our third rule with sig figs right now. And then we have to do times 10, and then the number we put up here as an exponent has to be how many times we moved our decimal point from when we started to when we ended. And so we can simply count 1, 2, 3, 4, So we moved it over 4 times to the left to make our number smaller. But our number to begin with was big, so we want to make sure to tell people, hey, you got to make this bigger by using a positive number here, so we're going to have it as a positive 4. Okay. I'm going to do one that's not on our worksheet, but it's going to show us a smaller number and how to convert that. So, special extra. Say you had the number 0.00006549. Okay, this is a super small number, and so we have to look at the numbers that are relevant. These zeros really aren't relevant. These ones are, so we're going to focus on them. So we have to look at our first digit. It's between 1 and 9, 6, so we're going to start with 6. Point. Follow our second rule, follow it with our other following numbers. Times 10. And the number we put in here, since our original number is small, we are going to be moving our decimal point down toward our relevant numbers. And since we're making this, you know, this number will be small, it will be a negative exponent. And we're just going to count the number of times that we move our decimal point over from here to here, which is going to be 1, 2, 3, 4, 5. So it's going to be a -5. Again, you can also count the number of circles you had between here and your number. So 1, 2, 3, 4, 5 to easily go, oh, it's a -5. But again, that's just a trick that I use, okay? So that's how we take normal numbers, or like standard numbers is what they're called, and make them into scientific notation. I'm going to take one from the opposite side of our sheet and do that one now. Let's do number let's do number number 9. Number 9 is 2.9854 times 10 to the -1. Now, if we look at this number, we know that this is where we start, because here's our decimal point, and it's a negative. So according to our sheet, if it's a negative, we have to have our decimals go to the left. So many people, when they look at these, they go, oh, we're going to go that way. Negative means it goes to the left. Only positive exponents go to the right. Negative to the left. So if we're going to the left one time, we have to take our decimal and go to the left once. So our new number, our actual standard number, is 0.29854. Okay. So don't let yourself be tricked by exponents. Just knowing which way they go helps you out a lot. Okay? Anyway, that's it for scientific notation. Sorry, this one was a little bit more long-winded, but I wanted to make sure that we understood the rules as well as learning which way our arrows go when we have different exponents. Okay? Hopefully this helped, and I'll see you in the next one. Bye!